Our topic is diode as a circuit element. You know the semiconductor physics of diode. I'm not going into it that. So let's see how can we analyze a diode when it is in a circuit. Okay. So let's say this is your diode. You know there are two conditions. One is when this is forward biased and the second is when this is reverse biased. When this is reverse biased, no current flows through the diode. So if you, let's say this is your diode and you give a negative voltage across it. This is minus plus E. This is your diode. So what happens? This is reverse biased. Current will flow in this direction. So this is reverse biased. What happens? When current is not flowing, you can assume it to be like this, an open circuit. Open circuit means this voltage appears here, this voltage appears here. So this is the voltage across the diode when it is reverse biased. Now when it is forward biased, this condition, when the diode is forward biased, you can represent it like this: a voltage source of V gamma, the threshold voltage, and a resistor. Many times this resistance is given, many times it's not given. So ideally this is not present, RF is 0, so that is simply a voltage source. But sometimes you will be given that the forward resistance of the diode is RF. So this can be represented like this. So if you have like this, you can write the equation I as, let's say this is I, then I will be, if this is E, so let's write the KVL, minus E plus V gamma plus I into RF is equal to 0. This is your KVL. So from here you can find the current. Current is E minus V gamma by RF. Now V gamma, you'll see it's given in your question. Sometimes it is given 0.6 volts, sometimes it's given 0.7 volts for silicon. Somewhere you will find 0.2, somewhere you will find 0.3 for germanium diodes. So whatever it is given in the question, you'll have to use it. So let's start with a very simple question. Let's say this is a 10 volt source and we have a diode here and a load resistor R. I am not going into waveform reconstruction, that what is the waveform at the load. I am just doing the circuit analysis, what is current voltage across different elements in the circuit. Let's say this is the case, this is a 10 volt source, this is a diode, this is a resistor. Let's say your V gamma is 0.7 volts of this diode. R is 1 kilo ohms. So what will be I? This will be equal to a voltage source of V gamma. So what you can write is minus 10 volts plus V gamma. V gamma is 0.7 volts plus I we have to find I into R. R is 1 kilo ohms is equal to 0. So from here you get I is equal to 10 minus 0.7 by 1 kilo ohms. Kilo becomes milli, so 9.3 milliamperes. This is the current in this circuit. Clear? So let's see some more examples and understand it. This is a circuit. This is a current source. This is a voltage source, a diode. This is again a voltage source, a resistor. This is grounded. V gamma for the diode is 0.7 volts. We have to find first of all what is the current, let's say I2 in this circuit, and current I1 in this circuit, and we have to find what is the voltage at this point, V1. Okay, voltage at this point, current in these two circuits we have to find. It seems difficult, but it's very easy. See, this is a 3 milliampere source. Current will get at this point, it will divide into this and this. That is, from here we doing KCL at this point, you know 3 milliampere is equal to I1 plus I2. I1 and I2 are in this direction and 3 milliampere in this direction. So this is the first equation that you get. Now, when current flows through this circuit, you know what will the voltage drop at this point. It will be like this, plus minus 0.7 volts, that is your V gamma. So now you see this is plus minus plus minus. So effectively what you have across these 2 points, this and ground, that is your V1. This is your V1. Clear? V1 is what? V1 is the voltage across these two. So this is actually 0.3 and 0.7. So what is V1? V1 is, the polarity will be different because we are taking V1 as positive. But here this is ground. So from here it is 0.3 plus 0.7, 1 volt from this to this. So V1 will be minus of this, minus 0.7 plus 0.3 volts. That is minus 1 volt. Okay. Now we have to find I1. What is I1? See, here we cannot find what is I2 directly because we have voltage but we don't know what current flows in it. The only way to know what current flows in it is if we know what is I1, we'll be able to get I2 from this equation. So what is I1? See, the voltage applied across this is this. So how can you find? And what is it? It is 1 volt. That is 1 volt is applied across this voltage. Clear? So you can go like this, I1 like this, minus 1 volt minus 1 plus 0.7 plus 0.7 and then you have plus I1 into 300 ohms. This is equal to 0. KVL in this circuit. See, minus 0.7 minus 0.3 minus 1 plus 0.7 into I into R. So from here what you get? I1 is equal to 0.3. See, to this side it is 1 minus 0.7. So 0.3 by 300. If we take milliamperes, we'll have to multiply it by 1000. That is this 0 then 0. So this is effectively 1. So this is 1 milliampere. So when we have I1 equal to 1 milliampere, I2 will be equal to 3 minus this 1. That is 2 milliamperes. Okay. So this is how we find current. We have two examples here. See, here we have plus 12 volts, 12 volt source. This is your first diode, a silicon diode. V gamma is 0.7 volts. This is a germanium diode. So this is 0.3 volts. V gamma. This is 5.5 kilo ohms. We have to find what is the current through this. Let's say I, and we have to find what is the V0 here. Okay. So if you are able to understand this circuit, very good. If not, this circuit can be, you can make this circuit like this. This will be a voltage source. This will be a voltage source. This one. This will be 0.7 volts. This will be 0.3 volts. Here you have V output. Here you have 5.5 kilo ohms resistor. And you can, because both are grounded, you can, this is 12 volts. Okay. So the equivalent circuit is not equivalent. This is the actual circuit. This is represented like this. So you have to find I. What will be I? See, I'm writing it here. Minus 12 volts plus 0.3, 0.7 and plus 0.3. See, this is minus to plus, plus to minus, plus to minus, and then I into 5.5 kilo ohms. So kilo, whatever it will be in milli. So I'm writing 5.5 only. I will be 12 minus 1 by 5.5 milliamperes. So this is 11 by 5.5 milliamperes. That is 2 milliamperes. So I is 2 milliamperes. Now if you want to see what is V output, V output will be what? V output will be voltage across this. So this is 2 milliamperes into 5.5 kilo ohms. So this will be 11 volts. This is 11 volts. If you go by this direction also, this will be 12 minus 1 volt. If this is V, then this is minus 12 plus 1 plus V. So there, see, if this is VL, which we have to find, this will be minus 12 plus 1 plus 1 plus VL equal to 0. From here also we have VL equal to 11 volts. Okay. Okay. Let's see the next question. Okay. So let's see this question. It is plus 10 here, minus 5 here. So equivalent circuit, you will have this as plus 10 volts. This is your first resistor, 4.3 volt kilo ampere ohms. This is plus minus 0.7 volts. Okay, let's say V gamma is 0.7. This is your V output. This is 10 kilo ohms, and here you have a minus plus source, minus 5 volts. This is the meaning of this. Let's say your current is I. So what you will do? Minus 10 plus I into 4.3 kilo ohms, 4.3 kilo into I, then plus 0.7 volts here, and then here you have 10 kilo ohms into I, and then here you have minus 5 equal to 0. So what you get? See, minus 10 minus 5. So here you will have, this side you will have 15 minus 0.7. Okay, and this side you will have 4.3 plus 10. So 14.3 kilo into I. Okay, so this is 14.3. So what do you get? You get I equal to 1 milliampere. So the current is 1 milliampere. And what is V output? V output will be, you can go by any side. Okay, so what you can do, let's say this is grounded. V output minus 5, that is plus 5, is equal to I into 10. I is 1 milliampere into 10 kilo ohms. Clear? You just forget about this part. This will be this minus this is the current in this, and we know what is the current. So this is this. So what is V output? V output is 10. See, 10 into kilo into milliamperes. So this is 10 minus 5, that is 5 volts. So voltage here is 5 volts. See this circuit. We have two diodes here. We have to find what is this current I, what is this is ID1, this is ID2. So what are these currents? It's very simple. Let's say the two diodes are identical with V gamma equal to 0.7 volts. Okay, so then this is 0.7, then let this be 9.3 kilo ohms. I'm just changing these numbers so as to find easy answers. See, this is diode, this is diode. So the voltage drop across this will be V gamma, that is 0.7 volts. So what will be I? I will be 10 minus 0.7 by 9.3 kilo ohms. So what you have? 9.3 by 9.3, that is 1 milliampere. So I is 1 milliampere. Now when these two are identical, ID1 will be equal to ID2. ID1 will be equal to ID2. That will be half of this I. Half current will go to this side, half current will go to this side, that is I by 2. So you will have 0.5 milliamperes in each diode branches. Okay, see this circuit. We have two diodes. One is in this direction, the second one is in this direction. Supplied voltage is plus 20 volt this side and plus 4 volts this side. Okay, and we have a resistor here, 15.3 kilo ohms. What we have to find? We have to find what is I, what is ID1, and what is ID2. We have to find this. Can you think of how to go by this question? It's very easy. See, this is plus 20, this is plus 4 volts. Therefore, the potential is higher on this side. This will be plus, this is minus. When this is plus, this is lower voltage. Current will flow in this direction. When it flows in this direction, this will be forward biased and it will cross this diode. but this will be reverse biased and it will behave like open source. So effectively the an easier picture would be like this. This will be 0.7 volts and this is your, so this is the actual picture. Because this is reverse bias, this will behave like open circuit. Therefore, your ID2, this is equal to 0. No current will flow in this direction. Why? Because this is open circuit. And what about this ID1? Obviously, ID1 will be equal to I, which is equal to, this is 20, this is 4. So, you see, this will be 20 minus, I'm doing this, minus 20 plus 0.7 and plus 4 plus 15.3 kilo into I. So what you get is I is actually 20 minus 4.7 by 15.3 kilo ohms. So this is 15.3 by 15.3, 1 and kilo becomes this. So this is 1 milliampere. Clear? Current will be 1 milliampere and this will go through this circuit. And this circuit will be open circuit. This is a circuit. This is basically AND gate. So we have to find the value of this output voltage V0 and different currents. Current in this part, this part, this part. The first is both voltages are 0. This is 0, this is 0. When both are 0, current through this is 0, current through this is 0. When this is 0 and 0, so current through this is also 0. So no voltage drop across this resistor, so the output is also 0. Clear? First case, all 0. Second case, it says V1 is equal to 10 volts, V2 is 0. So when this is equal to 10 volts, what we'll have? This is, let's say, 0.7. So we'll have V1 minus 0.7 by the resistor. Resistor is, if this circuit, this is 0, so just get this, just forget this circuit. So this is V1 minus 0 is the total voltage and resistor is 1 kilo ohms plus 9 kilo ohms. So this is 1 plus 9, that is 10 kilo ohms. This will be the current flowing in this circuit. Just forget about this. So this current will flow in this circuit. What is it? V1 is 10, so this is 9.3, 9.3 by 10, so this is 0.93 milliamperes. And when this is 0.93 milliamperes, what will be V output? V output will be 9 kilo ohms into 0.93 milli. So 9 into 9, 0.93, whatever be the value, this is the output voltage. Okay. Okay, let me just calculate it. So this is 9 into 0.93. So this is 8.37 volts. When your V gamma is 0.7. We have taken V gamma equal to 0.7 volts. If in the question it's given 0.6, you can put and the value will be changed. Now second case. Third case. Third is both these voltages are equal to 10 volts. See, this is 10, this is 10. This means the two potentials are same, both equal to 10 volts. Okay. So when you have this type of arrangement, effectively you will have 10 minus 0. See, 10 minus 0.7 volts will be what you are actually supplying. And this will become, because these two are at same potential now. Sorry, this potential and this potential. So these two will be in parallel. So total resistor will be 9 kilo ohms plus 1 and 1. So this will be 0.5 kilo ohms. So the current flowing, this current, that is this current, will be this. So you can find out what is this. This will be 9.3 by 9.5 milliamperes. So you can find the current here. And so V output will be whatever this current you find. So 9 kilo ohms into this current. This will be your voltage across this point. Okay. This is a Zener diode. So our example is, we are given E is 16 volts, R is 1 kilo ohms, RL is 1.2 kilo ohms, and VZ is 10 volts. See, whenever you have a Zener diode, what is the meaning of Zener diode? Zener diode means whatever VZ is specified, if the voltage across this is above this voltage, it will be at this only. That is, if in this condition you have voltage across RL above 10 volts, when this is removed, if the voltage drop across this is above 10 volts, this will be in on state and VZ voltage will be maintained. For example, if this is 10 volts, this will be 10 volts. Then whatever be E can, you keep on increasing E, the value of VZ will be same, that is 10, and whatever current will be flowing. So the first thing that we do is check for state of the Zener. How we check? Just forget about this. Just think this circuit is open circuit. Then what is the voltage drop across these 2 points? How we can find? Let's say the current is I. So I will be equal to E by R plus RL. Here if we put, what we get? E is 16 volts, R 1.2. So this is 2.2 kilo ohms amperes. So this will be 16 by 2.2. 16 by 2.2, that is 7.27 milliamperes. So what is the voltage drop across this point? That is voltage across RL will be I into RL. I you have 16 by 2.2 K, and RL you have, RL is 1.2 K. So K cancels. So this is 8.72 volts. Now see, the voltage across these 2 points is 8.72, but VZ is 10. So this is less than VZ. This means this will not be in on state. So the current in this circuit will be this and voltage will be this. This will be in off state. That is, current through this circuit will be 0. IZ will be 0. Okay. Now, for the same circuit, if we change the value of RL to 3 kilo ohms, then what? Let's see. If we change the value of RL to 3 kilo ohms, then your current will be what? Current will be 16 by R will be 1 and this will be 3. That is 4 milliamperes. Therefore, voltage across this load resistor will be 4 milliampere into, this is 4 and RL is 3. So this is 3 kilo ohms. So this will be 12 volts. Now you have a voltage that is greater than VZ. This is greater than VZ. Therefore, now this circuit will, this diode will be in on state and this circuit will be on. This means the voltage across this will now be equal to VZ only. In that case, let's say this current is I and this current is IL and this current is IZ. Then what? See, your IL will now be, this is VZ by RL, that is your VZ is 10 volts. 10 volts by RL and RL is 3 kilo ohms. So this is 10 by 3 milliamperes. Okay, and I will be equal to, this is 20. So 20 minus VZ, that is 10 by this is 1 kilo ohms. So this will be 10 milliamperes. So when this is 10 milliamperes, I is 10 milliamperes, what will be IZ? IZ will be I minus IL. I minus IL. You can do KCL at that node. So I is 10 minus, this is 10 by 3 milliamperes. So this is 30 minus 10, that is 20 by 3 milliamperes. Okay. This is how we analyze circuit when we have a Zener diode. So you have seen how diode circuit, a Zener diode circuit is analyzed, I'm giving you some concepts because that you'll need when you'll be solving questions. You can solve questions the way we did at that time. Let's say this is Vi and this is a resistor at this point. Here we have a Zener diode and we have a load across this. Let's say this is RL. Now, what is the voltage across this load? Let's say this is VL. What will be VL? You know, this is series circuit, this and this. VL will be, when we have taken this out, VL will be equal to RL VI, if this is VI, by RL plus R. Okay. Now, if we have to find what is the minimum value of the load resistor for which this will be in on state. On state means this is Vz. So, minimum value of RL will be when this VL is equal to Vz, not more than that. In the last question we saw it was 12 volts and Vz was 10 volts. So, we said current will flow and this will be in on state. But if exactly it was 10 volts equal to Vz, then for some particular value of RL, this would have been exactly equal to Vz. That we want to know. That is the minimum value of RL. So, this will be Vz. This is RL. RL Vi is equal to Vz RL plus Vz R. So, we can take RL this side, then RL, this will be R into Vz by Vi minus Vz. This will be R minimum. So, this way you can find what is the minimum value of the load resistor for which Vz will be in on state. Okay. Also, you may be given, and when this is minimum, this means this current will be maximum. If this is I, for RL minimum, this R plus RL will be minimum. Therefore, we'll get I max. This current will be maximum. So, either way, if the question says for what value of RL I will be maximum, so that will for the minimum RL value, you can find RL minimum and from there you can find current. Sometimes it is given that the maximum current that can flow through this particular circuit is IZM. Then find what is the value of this. Very simple. If we know IZM, from here we know I is equal to IZM plus I load. So, if this is given, from here we know that IL can be this only, I minus Zm, and then putting this we can find what is IL into RL. IL into RL will get Vz. So, based on what value we have, you can always find the particular current or voltage. The only thing is you should have logic. Circuit will be this. When you have to find the maximum current, this means the resistor has to be minimum. If it says these resistors are fixed, then obviously if you have current, you can find what is the input voltage, that is the voltage at which this will be possible. So, these are certain permutations and combinations in this type of circuit that you may be asked. The basic circuit is this and you should understand how to solve it. Whatever be the question, you can put values and get the result.